Welcome back, everybody. We are going to start our Chapter 3 unit with functions. Let's start with the difference between a function and a relation. A relation pairs inputs with outputs. So a relation can be a list of ordered pairs, and so on. It can be an equation, or it can be a graph. Because on this graph, we have inputs and outputs. We have to input an x value to find a y value to make the graph. So a function then is a special relation that pairs each input with exactly one output. And I like to say, in other words, x values are not repeated. So that's not the official definition. That would be in your definition section, like on a quiz or a test. But just to kind of help get what exactly one input and output means, the x values are not repeated. Y values can be, but x values cannot. So let's take a look at these examples. This is a relation because we have a list of ordered pairs. You're comparing, you have an input paired with an output. Like our input is -2, our output is 2. Our input is -1, our output is 2. Our input is 1, our output is 2. So this is a relation. The question is whether it's a function. And so basically what I'm doing is I'm looking at the x values or the inputs, and I'm saying, is anything exactly the same? -2, -1, 0, 1, 2. And the answer is no. So yes, this is a function because no x values are repeated, or there is exactly one output for every input. For number 2, again, this is a relation. We have ordered pairs. We have inputs and outputs. As I'm looking, though, I see this 4 and this 4. So that would mean no, this is not a function because 4 has a 0 and a 3, which are 2 outputs instead of 1. So the 4s are repeated. Example 3, inputs and outputs, x's and y's. I'm again kind of looking here, there's 2 zeros. So the 0 input has an output of 5 and an output of 6. So no, this is not a function because the zeros are repeated. If I look at example 4, I'm okay if there's 2 y values that are the same, but not if 2 x values are the same. And right now, I only have one line going from each x value. So if I had this, that would be 2 lines coming from the -1, which would mean it's not a function. But because that's not the case, and we only have one line from each x value, then yes, this is a function because there is exactly one output for each input, or x values are not repeated. You please do the U-Tries 5 through 8. The vertical line test. So a graph represents a function when no vertical line passes through more than one point on the graph. So a vertical line, remember, is a line that is straight up and down. Straight up and down. So this right here is a vertical line. Sorry. Let me get this pen back. This vertical line is straight up and down. And when I pass it through any of these areas on the graph, it only touches the plotted points one time. So this is a function. It passes that vertical line test. Now this one on the right is not a function because as I draw any vertical line anywhere, there are several places, almost everywhere on this graph, where it touches twice. And when that one line touches twice, it is not a function. Examples. So as I'm looking at example 9, I go here, yep, it only touches one dot, but as I go right here, it touches 2 dots. So this is not a function. For number 10, if I do vertical lines here, anywhere on this graph, it only touches that graphed line one time. So this is a function. You try 11 through 14 with that vertical line test. Domain and range of a function. So the domain, we're talking about x values here, is the set of all possible input values or x values. The range, y values, the set of all possible output values. So your range is listed on the graph going from the left side to the right side. The range is listed from a graph going from the lowest point to the highest point. So left to right, lowest to highest. Let's try a couple of these. This is our function machine. 15. So I have 1, 2, 3, 4 dots. So I just need the ordered pairs of these 4 dots. This ordered pair looks like -3, -2. This is -1, 0, 1, 2, and 3, 4. So that makes the domain of 15, listing all of the x values. We have -3, -1, 1, and 3. The range is our y values. So we would list the range as -2, 0, 2, and 4. For 16, these are supposed to be filled in here. Rather than having individual points, we have a graphed line. So these ones are going to look a little bit different than the other one. So our domain, the furthest left is here when x is -2. The furthest to the right is over here when x is 3. And everything is shaded in from -2 to 3. So we will write this as -2 is less than or equal to x is less than or equal to 3. So that means I can have absolutely any x value I want from -2 to +3. For range, we're looking at the y values. So lowest, which is here, to the highest, which is here. This y value is, let's see, this will be -1. So -1. The highest value here is 2. And then we write this the same way, just with an x. Or sorry, with a y. Go ahead and leave the UTRI 17 and 18. We'll talk about those in class, clear this up even more, and do some further examples. Independent and dependent variables. So the independent variable typically is going to be x on our coordinate grids, is the variable that represents the input values of a function. So again, it doesn't necessarily have to be x. It can be any letter that's representing an input. But for our coordinate grids, our graphs, they will be x. If I'm looking at the dependent variable, again, talking about our graphs on our coordinate grid, those would be the y values. But these would be the variable that represents the output values. They depend on the input values. So let's talk about that in an example. We're talking about juice that's in a bottle and you're taking gulps. So we talk about independent and dependent variables. Well, the amount of juice that you have left in your bottle depends on how many gulps you're taking. So juice remaining depends on gulps. That means your dependent variable is the juice remaining, which in this case is y, and the independent variable is gulps, which is x. Let's take a look at number 20. We have a function that says the cost for t-shirts plus shipping. Well, we have to plug in how many t-shirts we're ordering to know our cost. So cost depends on the number of shirts. That means our dependent variable is our cost, which is C, and our independent variable is the number of t-shirts we choose to order, which is T. I'm going to go back to 19. The domain. They're telling us that our domain is 0, 1, 2, 3, and 4. So our x values, we are going to plug in 0, 1, 2, 3, and 4. We plug in x, we find y, and that's how we get our range. So y is equal to negative 3 times 0 plus 12. 0 plus 12 is 12. So our range, we have 12. Then we're going to plug in the 1. So negative 3 times 1 is negative 3. Negative 3 plus 12 is 9. So our next number is 9. Then we're plugging in 2. So negative 3 times 2 plus 12. Negative 3 times 2 is negative 6. Negative 6 plus 12 is 6. So our next number in our range is 6. To plug in 3 now. So plug in 3. Negative 3 times 3 is negative 9. Negative 9 plus 12 is 3. And then our last value to plug in is the 4 from the domain. Remember, domain is x values in this case. So negative 3 times 4 is negative 12. Negative 12 plus 12 is 0. So if our domain is 0, 1, 2, 3, 4, our range is 12, 9, 6, 3, 0. Technically, we should have that in order from least to greatest, but for right now, this is fine. Let's try number 20. So again, we have a domain. If we didn't buy any shirts, then we wouldn't really need this equation. So that's why we don't have 0 here. But let's say we're going to choose to buy 1 shirt, 2 shirts, 3 shirts, 4 shirts, or 5 shirts. These are x values, or in this case, t values. So we're plugging these in for t, our independent variable, to find out how much it will cost us to ship. So C is equal to 6 times 1 plus 8. 6 times 1 is 6. 6 plus 8 is 14. So our range starts with 14. Then we are plugging in the 2. So 6 times 2 plus 8. 6 times 2 is 12. 12 plus 8 is 20. So our next range value or output is 20. Then we want to plug in the 3. So 6 times 3 plus 8. 6 times 3 is 18. 18 plus 8 is 26. So our next value is 26. Our next input for T is 4. So 6 times 4 is 24. 24 plus 8 is 32. So our next value in our range is 32. And then last but not least, we're plugging in 5, our input value, our domain value of 5. So 6 times 5 is 30, and 30 plus 8 is 38. That's our last range value. All right. Try numbers 21 and 22, and I will see you next class. Have a great one.